Okay. So, hi, my name is Henrik Göthberg. I'm the founder of DAIRDUX.
Mikael, Klingvall, senior med scientist at DAIRDUX.
We will talk about data decision flows and address you from an angle starting very similar as the Airbus presentation. So we have worked with the Vattenfalls and Scanias, Boliden in mining, and Tetra Pak, and on the core topic of designing.
Hold on. I just want to say we're very grateful that Vincent presented before us, because what we're doing is a generalization of the things he's talking about.
Yeah. So let's launch into it. And the core topic of talking about data decision flows, intelligence.
Yes. And?
Talking, so I think the core topic that we will launch into now is being flavored right now, but a lot of stuff that happens right now, and a lot of buzz that's going on. And this is one of the last articles with a very clickbaity title: Agentic AI, decisive operational AI arrives in business. I'm going to have a problem without seeing the slides here, but let's try it. So that's an interesting topic, but why is it interesting? I think one of the things that we are thinking about, and what we want to discuss and reflect about, is that when you make a statement that the way we design systems and AI can go from jobs of 5 seconds to 5 minutes to 5 hours, it really puts this thinking on, well, how do we design decision flows, data decision flows then? How do we organize this?
Yeah, I'd say that when the AI can do serious chunks of works autonomously, we have to rethink how we organize our data decision workflows.
Yeah, and Vincent said it well. Are we talking about augmentation or automation? Will we have something doing 5-hour work for us, or will we interact with it completely differently?
So agentic AI, as soon as we talk about agentic AI in intelligent maintenance, we have to wonder, whose intelligence? Are they behaving intelligently? Which decisions do they make? And for whom do they make this? Are they helping? And what are they doing?
But hold on, what do we even mean with agentic?
It simply means behaves like an agent, human or artificial.
Can you unpack?
Sure. So an agent has to be able to act, learn, and decide. So we talk about agency, which is the ability to do things and accomplish outcomes. We talk about adaptability, which is the ability to learn from mistakes. And we talk about autonomy, which is easily the most philosophically complex concept here. But for now, let's just say it's the ability to make decisions about future actions.
So what I take out of that, if I'm going to print a T-shirt, it would say agency rules. And what we mean with that how we design agency, how do we think about that concept? Because we want to accomplish stuff, has profound implications from the model design to the system architecture design, to the UX design, to the workflow design.
Hold on, because I'd say that, sure, agency is important, but it's very important to decide which outcomes are the right one to try to accomplish.
Yes, just to have agency and do shit is not enough. You need to do the right stuff. And that is, as we saw with Vincent K, not always easy to decide.
We need to think about what constitutes intelligent behavior in these workflows, and that is about feedback mechanisms. So, agentically speaking, intelligence emerges from groups of agents or agentic entities interacting, adjusting to each other. And each of them learns from the consequences of their actions, feeding back to them as inputs for their future actions. So cooperative groups of people or things. intelligence, and specifically intelligent behavior, is agentic. If you think about what constitutes an intelligent system, like Dario talked about, it's agentic. The agents of that system make the system behave intelligently.
So we're using a lingo now, which is found in the AI research field, to talk about stuff that we do all the time. So this becomes quite interesting. If we're gonna explore this topic, how would you take that into a data decision workflow? And let me have a shot at it. And everybody now have the Airbus presentation on how they have designed their data decision flows. You had some different roles, they were doing different things. So this is what we're talking about: the data, predictive maintenance into a control room, someone else making the decision, people and humans. So very simply put, maintenance orbits then around data collection, the processing, analytics into decision making. So then we need to, of course, do who is doing the data work all the way through in order to augment the decision.
And that goes both ways, because we need to be able to make decisions about what data to use, how to use them, who does the data work, how do they do the data work.
Yeah, I mean, like the data over here is, we found out that it's really crap. So you now need to fix the data quality over here. So it's constant feedback loops.
Within one domain, because now we have a data decision workflow that is within one domain. Yes. And that means, and this workflow interacts with other workflows or is part of other workflows, other parts of the organization.
And of course, we saw that with the case. We have the data around maintenance, but we need scheduling data from the scheduling system, if that's Amadeus or something else. So all the data that is in your beautiful system needs data from another beautiful system and teams in order to understand what is the right decision.
So we have agents leveraging tech to do work in workflows across or between domains. Data decision workflows are sociotechnical systems created to accomplish outcomes for agents, by agents, through other agents, leveraging technical system with agentic entities or intelligent systems.
So we have a tendency to talk about this in the system world, and then we talk about this in the business world or the process world. And we have found sometimes that there's a huge disconnect how the industry in data and AI, they talk about data warehousing and design techniques, and we look at the technology and what we can do.
Get on with it.
But we live in the world of Airbus in reality. So the core topic then is that, well, it's not that hard really. It's the complete system of the social part, what the people are doing and making decisions, and the tech part that we decide to use. And these kind of need to work together. And this kind of got a little bit more exciting or interesting or scary when we have more autonomous or agentic ways of doing intelligence.
Hold on. So managing anything socio-technical benefits from explicitly taking an agentic perspective. Now, when we have agentic resources, do they go into the HR department or the IT department?
Yeah. But even one of the core hard tricks here is to find a lingo, a way to discuss this that makes sense when we design and make boundaries of models, architecture of systems, processes. So having an agentic understanding and learning and doing those kind of methods allows us to work on these, discuss these fractally, instead of having the challenge between the engineers discussing and describing it in one way, and then we describe it in a completely different way in business. So having a lingo that sort of follows could be useful. But now we come to the next question that sort of pops up in my mind. Have we really had this agency topic in mind when we organize our organizations? Are they built with that design goal at all?
Typically not. Because in organizations, what we usually see is functionally stupid behavior rather than intelligent behavior. Because the ways in which we organize and the ways in which we work can easily make smart people do stupid things.
Yeah, so we had our organizational objectives that weren't always where agency was the main idea. I mean, like we talk about functional division of labor for have efficiency. We talked about roles, not teams, task machines. So we have a lot of legacy here in organizational theory that doesn't really match where the theory is going with AI. And somewhere in the middle here, we have the reality of Airbus, where we have teams working together to accomplish stuff, to take decisions.
Short side note, the ref here, Mats Alvesson and Andre Spicer in 2012 published the best article on organization for the last 100 years. It's called A Stupidity-Based Theory of Organizations. It's hilarious. It's the best. You have to read it if you're interested in organization.
Yeah. So, and of course, then we get to the point of how do we work on these topics? You know, when we are not in the lab anymore, but we are really out there in the field, trying to design, trying to work on these topics. Drucker says it quite well, you know, it requires leadership, okay?
Leadership, since everything else requires leadership, this ties in with what John P. Cotter says about change, because he says, he makes the distinction between management and leadership. Managers cope with complexity. They do admin. Leaders cope with change.
Yeah, but change for what? I mean, like in the large organization, change is painful. So here's the point. We need to have a clear direction. What are we leading towards? What is the focus of this leadership? We want smarter decisions. Abstractly, we want to be more effective.
Because we want intelligent behavior in our organization.
Yes, preferably. So one way of looking at that, I argue, or we argue, because we are coming into these topics where we see a lot of in solutions where there's a lot of research, there's a lot of design methodologies that are addressing exactly these topics. If we go into software engineering, data engineering, and talking about how we design systems. So separation of concerns and those topics, cognitive load, Conway's law, all these things, of course, is already there. So why don't we just get on with it?
For the very simple reason, these books are brilliant, but they are narrow in scope. They talk to software developers. They talk to the people who organize software developers. And they talk about data management and data engineers. We need to extract a heuristic that can function as an organizational design pattern that is universal for the organization using a lingo that's applicable across the domains.
So if we can't find words to describe and discuss about this that actually make sense for the hardcore AI engineer, how he thinks about agentically organizing models, all the way to how we agentically trying to organize platform versus domains in a data mesh architecture, all the way to how we then understand agentically what teams should be doing what, how should the boundaries be. Finding that common language so we can sort of bridge from the different disciplines. That's what we're talking about. So we then said, okay, can we extract, if we like these books, what are the commonalities, or are there some common themes where we can talk heuristics? And there is. Like one core example here is in data mesh. When we're talking about how to organize platform engineering, we talk about infrastructure self-services. So organizing infrastructure as a way for a domain team to be able to work with data engineering locally without needing to worry so much about infra. And then we talk about team topologies.
Yes, the main interaction mode between teams in the team topologies is X as a service, providing an interface to other agents, other teams, other units, other workflows that they can use on their own time, in their own time, on their own when needed. Self-services.
So we get to something that, you know, we can start reasoning about what's some fundamental heuristics or ways of thinking that we can apply fractally. And then we take another angle into this, and when we read Christian Claytonson's The Job to Be Done theory, he, from a marketing point of view, if you like, he sort of frames it from another way, and it's sort of, you can use that to start finding principles around how to design stuff. And so let's call this the boost heuristic.
With agency rules.
Yeah. And other agents then reaching for new ways to get their jobs done. I need to read. Frames the job to be done, the boost, purpose, and the team's required mastery. I'll take it. So very simply put, finding principles as a way to guide us in our ways to think about how we improve, how we design stuff.
The problem is, this simple idea is very admirable, and we should work this way, but it doesn't scale. Because we need to ensure that we have high cohesion and low coupling. So we can have effective agents adapting on their own to and adapt to and interact with other agents. So we need rules on agency. Well, not rules, guidelines. But I mean, agency rules sounds cool. It makes a t-shirt. And those two rules are that products are team-sized. We had a discussion with Matthew Skelton, one of the authors of team topologies. We're discussing team cognitive load. And team cognitive load is the main limiting factor for getting things done in organizations. Because we need teams because they usually perform better than individuals do.
Yeah, so team cognitive load, and then of course, then we have.
Sorry, I haven't finished. Making teams the pivotal unit of action and the agent of change. So products are team-sized.
So products are team-sized to describe how do we design AIs, assistants, processes as a way to have high cohesion within the team. There is a boundary of how much should be inside that container. The other interface is describing, articulating the decoupling mechanisms. So teams, we need decoupling mechanisms in our systems, but also in our teams to work effectively. And so the core topic here is then, finding a lingo, finding a conversation that guides us when we're making choices in how we design flows, how we design organization, how do we design systems, how we design AI agents.
I think it makes sense to visualize this as a graph, actually. But yeah, we'll take this.
Yeah, and maybe a little way so to sort of understand what this leadership is all about, or what this change is all about. It's a little bit contrasting more on an organizational point of view, where we are coming from with functional division of labor and what is the option. And if I start with the boost heuristic, I mean, like the first heuristic, it sort of highlights that if you're having a heuristic where you are there to boost someone else, it's quite different to have your main objective to be self-absorbed, trying to be cost-effective on your own. So the way we're driving efficiency and discussing inwards efficiency tends to make us do functionally stupid things in terms of getting, moving friction to someone else, or making us more and more.
In short, functional division of labor creates friction, confusion on the performance.
Because we are tending then to focus inwards rather than focusing making ourselves as a job to improve someone else. If you take that mindset into an AI model where you put the AI objective function to be inwards looking instead of sort of making sure that it fits and really supports the human or supports the ecosystem, it becomes quite scary.
And we can apply the same thinking to the agency rules. So if we take the rule that products are team-sized, in an organization dominated by functional division of labor, we have the functional units are workers and units, of course, and departments. These are treated as task machines with minimal agency and autonomy. This results in silos with low cohesion and high coupling. You have a web of dependencies and blockers because they don't have autonomy. Yeah. So we need booster teams with agency and autonomy so they can get shit done and accomplish outcomes, making them so the teams are the main vehicles for making a difference for the other agents, the workflows, and achieve changes that stick.
Yeah, and this sometimes, we today, when we have organized, like these are the domain people, they know the domain of whatever they're maintaining very well. But they don't really have any data people in there. They don't really have any data scientist people in there. So from that sense, they are not autonomous to work the data decision workflow alone. So then they need to go to IT and, you know, do a ticket because they need another data set. So this is what we mean with the task machine. You're highly intelligent people working very autonomously, but they don't have the core mastery of the data dimension, the data science dimension, and the domain inside to be autonomous truly.
Should we make an actual example here?
I think there are tons of it. I mean, like if you take an example of, we want to be more, we want to have more data decision flows, and then you come to the topic of discussion between business and IT, budgets. Take a simple topic about data quality and taking a data ownership perspective. It's IT that should be doing that. But IT doesn't know the stuff that needs to be known in relation to the mechanics of an aircraft. So here we have we're so ingrained in how we think about what is business versus IT and how we have organized this. So it's really hard to be autonomous on those topics until these things are more deeply understood end to end.
The second agency rule, product as interface, with a functional division of labor, we have high coupling, which impedes efforts to boost workflows and increases both the blast radius of any change and team cognitive load. And the only workaround here is you have to work around the problems and create point solutions.
Yeah, so typically
it becomes a mess.
It is tricky because we get to a point where either we build really big systems that should be able to do everything, and then they become monolithic in their approaches. And when you have a very monolithic approach, don't touch it, don't touch it. And how now we want to adapt models dynamically over time. We need to work on maintenance in different innovation cycles. Like the mechanics has one innovation cycle. Software has a completely different innovation cycle in terms of how we can introduce algorithms.
So the way we achieve low coupling is by thinking in terms of providing self-services. Make yourself useful. Provide something that others can use in their own time, on their own terms.
Yeah, so the simplest form we understand this in the software world is APIs. So we build our systems in such a way, so we are doing a function, we're doing a microservice, we're doing something that other functions can use. So this adaptability topic becomes then how you containerize the different parts important.
Can we get to the visualization as a graph now?
Yes, I mean, like, so if you look at this now, because these are now ideas and principles, like where are we going with agentic AI, and can we learn something from that in terms of, you know, working on these topics on the data decision workflows? And one way of looking at that sort of is, how do we start with this in the business side to really understand the bigger picture organization of people that need jobs to be done, and who is serving them, and how they are then served recursively in the same way by maybe other teams that's working further back. If you take the example in a large enterprise like...
I have to interrupt because we have some dark circles here around the different domains. They don't show up on this screen, which makes this a little bit more difficult to interpret.
No, but if you take 1 minute to dissect the picture. So this is in a large enterprise like Vattenfall. This is one domain. Are we doing predictive maintenance on wind farms? Great. By the way, we're doing predictive maintenance on nuclear power plants as well. Okay, so that's another domain working over there on their problem. Ultimately, going from point solutions to how do we work with technology broadly, how do we work with patterns broadly so we can share data between different things. I mean, like a good case study is, how do we do return on capital employed, ROCE, optimized maintenance? So how do I decide how to do and schedule planned maintenance on wind farms offshore in relation to the spot price of energy, in relation to spare parts, in relation to people, in relation to boats available, in relation to inspections?
Really, I'm starting to get a sense that since most organizations are dominated by a functional division of labor, which tends to induce functionally stupid behavior, the hype around artificial intelligence becomes a problem. I mean, the best case scenario when organizations employ AI is that it results in innovation theater. So it more or less we need to come up with an AI strategy. We need to come up with a portfolio of AI use cases because we want to look good to investors and the owners. We have the appearance of being at the forefront of the AI revolution while continuing to do business as usual, mostly.
And that's
the best case.
This is the send-off. This is the end note. So what we have seen is sort of there's a quite huge divide between projects, what we can do and what we have shown in the lab, and can make things work, and then asking the question, what machine learning is in production at Airbus in the maintenance decision flow, and we are back to Gaussian curves, as sort of or we are back to we need to do stuff, but we will not go anywhere if we don't get it into the human in the loop decision making, the sociotechnical systems. We will do a lot of cool stuff in the lab, but ultimately reality hits, regulatory hits, and then all of a sudden, how we have thought about this the whole way and how we can describe it and have principles that works from the machine learning algorithm to the organizational and regulatory contexts.
I mean, really, if you think about it, we need a sort of a cultural shift now that our machine learning techniques are producing learning machines that learn on their own. We need to shift our cultural perspectives from the systemic to the agentic, because the agents and their interaction is what give the systems the ability to behave intelligently. So we need some sort of a reform, an agentic reform to fight AI hype.
Yeah, and with that, I think we stop here. So hope that evoked some thinking.